Hello friends, welcome to H2 Diamond Academy. In the last lecture, we have discussed up to question number 12. So we will discuss question number 13 onwards in this particular lecture. So basically, we are discussing the problems on the Stokes theorem. So in the last lecture, we have discussed up to question number 12. So we will discuss question number 13 onwards. So let's start our discussion. What we have seen in the previous set of lecture is that, so the basic expression for the Stokes theorem is f dot dr along the curve C is equal to surface integral along the surface S. This is curl of f dot n cap into ds. Okay, so this is the basic expression for the Stokes theorem. So okay, so let us understand this. So let us consider a surface S like this, which is being bounded by a curve C. Okay, so this is our curve C that is bounding this surface S. Okay, this is our curve C, and this is the unit vector along the outward normal. Okay, so outward normal is in this particular direction. So from right hand thumb rule, so the order of this curve C is in anti-clockwise direction. Anti-clockwise direction. Okay, so let us write down the Stokes theorem. So we have along the curve C, that is f dot dr along the curve C, this is equal to surface integral along the surface S. This is curl of f dot n cap into ds. So this is the basic expression for the Stokes theorem. This is Stokes theorem. Okay, now let us start discussing the problems one by one. Okay, so in the question number 13, we have to verify Stokes theorem. The value of f is given by minus y cube I cap plus x cube j cap, where S is the circular disk. S is the circular disk, that is x square plus y square less than equal to 1, z is equal to 0. This means this circular disk is lying in the xy plane. Okay, so let us verify Stokes theorem. Okay, so this is solution of question 13. Okay, so we have the value of f is equal to minus y cube I cap plus x cube j cap. Okay, and S is the circular disk that is given by x square plus y square less than equal to 1 and z is equal to 0. So this means the circular disk is lying in xy plane. Okay, so let us verify the Stokes theorem. So we have the expression for the Stokes theorem as f dot dr along the curve C is equal to surface integral along the surface S. This is curl of f dot n cap into ds. Okay, so since the xy plane, so the circular disk is lying in xy plane, so we have the n cap will be equal to k cap. Okay, and now let us find the curl of f. So curl of f is equal to I cap, j cap and k cap. This is del upon del x, del upon del y and del upon del z. So curl of f is del cross f. So first we are writing the components of del operator, that is nabla, and secondly we will write the components of f, that is vector point function. So this is minus y cube and this is x cube and this is 0. So this is equal to I cap, this is 0 minus 0 plus j cap, this is del upon del z of y cube. So no term of z here, this is 0. Similarly minus del upon del x of 0, this is 0 plus k cap, this is 3x del upon del x of x cube, del upon del x of x cube, this is 3x square and plus this is 3y square. Okay, so this is equal to 3 times of x square plus y square k cap. This is curl of f. Okay, so this is the value of curl of f. Now let us find curl of f dot n cap into ds. Okay, so we have the circular disk like this. Okay, so let us take an elemental area. Okay, let us take an elemental area ds. Okay, so this is at an angle of theta from the horizontal. Okay, so let us take this as theta and this as d theta, and this is at a distance of r, so this is dr. So ds is equal to r d theta into dr. Okay, so ds will be equal to So this is our ds. So ds is equal to, this length is r d theta and this length is dr. So we have like this. This is r d theta and this is dr. So ds will be dr into r d theta. So this we can write as r dr d theta. This is ds. Okay. And we have curl of f as this one. So we have the expression for curl of f dot n cap ds. So curl of f dot n cap ds along the surface S. So this is equal to, curl of f is 3 times of x square plus y square k cap dot n cap is k cap because our circular disk is lying in the xy plane. So unit vector along the outward normal will lie along the k cap. So this is k cap and this is ds we can write as r dr d theta. Okay, so along the polar coordinates we have x is equal to r cos theta and y is equal to r sin theta. So this is equal to 3 times of, this is integral along the surfaces. So this is 3 times of x is equal to r square cos square theta plus y is r square sin square theta into r dr d theta. Okay, let us place the limit here. So r varies from, so limits on the r will be, limit on r will be, the radius of this circular disk is 1. So r is equal to 0 to 1 and theta varies from 0 to 2 pi. So this is equal to, when we take r square common, this is cos square theta plus sin square theta. This is 1. This is r square and this is 1. And this is r. This is r cube dr and this is d theta. Okay. So r varies from, r is equal to 0 to 1 and theta is equal to 0 to 2 pi. Okay. So this is equal to curl of f dot n cap into ds and this is along the surface S. So this is equal to, this will be r4 upon 4 and limits are from 0 to 1. So this is 1 upon 4 into, this is d theta. So this is 2 pi. And this is equal to pi upon 2. Okay. And we have this as 3 here. So this is 3 and this is 3 times. So this is 3 pi upon 2. Okay. So the value of curl of f dot n cup ds, this is equal to 3 pi upon 2. Now let us find f dot dr along the curve C, that is line integral. So we have f dot dr along the curve C. So this is equal to, the value of f is this one. So this is equal to minus y cube I cap plus x cube j cap dot product with, this is dr. Dr we can write as dx I cap plus dy j cap. This is equal to minus y cube dx plus x cube dy. Okay, this is the value of f dot dr along the curve C. Okay, so this we can write as minus y cube into, in the terms of parametric form. So this is d, we can divide by dt and multiply by dt. This is y cube dx upon dt plus x cube dy upon dt into dt. Okay, so in terms of parametric form, we can take the value of x as, x is equal to, this is x square plus y square is equal to 1. So we can take x is equal to cos t and y is equal to sin t. Okay, so this is equal to minus y cube. So minus of y cube will be sin cube t into dx upon dt is minus sin t. Okay, dx upon dt is minus sin t plus x cube we can write as cos cube t into dy upon dt is cos cube t. Sorry, dy upon dt is cos t into dt. Okay, and limit on dt will be 0 to 2 pi. Okay, so in the term of parametric form, x is equal to cos t, y is equal to sin t and t varies from 0 to 2 pi. Okay, so this will be equal to sine 40 plus cos 40 into dt, and this is 0 to 2 pi. This is the value of line integral along the curve C. Okay, so we can divide this by 4 and multiply by 4, and we can take 4 outside, and 2 pi by 4 is pi by 2, pi upon 2. Let us expand this. So this is equal to 4 times of sine 42. So from sine rule we can integrate this. So this is equal to divided by 4, and this is 3 into upon 3, and this is 2. Okay, sorry, this is 3. We can we have to subtract 1. So this is 2 and this is 1. 1 by 2, and this is pi by 2. Similarly for cos 40. So we can multiply this by 2. So this gets cancelled and this gets cancelled. So this is equal to 3 pi by 2. Okay, so this is same as the value of line integral is 3 pi by 2, and value of surface integral is 3 pi by 2. So this way we have verified the Stokes theorem. So now let us discuss question number 14. Let us discuss question number 14. So in question number 14, evaluate surface integral del cross f dot n cap ds, where value of f is given by this particular expression, where s is the surface of cube given by y is equal to x is equal to y is equal to z is equal to 0. Okay, and x is equal to y is equal to z is equal to 2 above xy plane. Okay, so let us evaluate this surface integral. So we have the value of the vector point function. So this is solution of question number 14. So we have the value of f as f is equal to y minus z plus 2 I cap plus yz plus 4 yz plus 4 j cap minus xz k cap. Okay, where s is the surface of cube. Let us draw the cube. So we have the coordinate axis like this. This is x, this is y, and this is z. Okay, so we have x is equal to, so the surface of cube is given by x is equal to y is equal to z is equal to 0, and x is equal to y is equal to z is equal to 2. So let us draw x is equal to 0. So x is equal to 0 is this one. Y is equal to 0. Y is equal to 0 is this one. Okay, y is equal to 0. Sorry, y is equal to 0 is this one. Y is equal to 0 means xz plane. This is y is equal to 0, and z is equal to 0 means xy plane. Now x is equal to y is equal to z is equal to 2. So x is equal to 2 means this one. This is x is equal to 2. Y is equal to 2. So y is equal to 2 is this one. This one is y is equal to 2. And z is equal to 2. So z is equal to 2 is okay. This is z is equal to 2. So this is our cube. Okay, and we have to find the value of surface integral. This is surface integral. So we have to find the value of surface integral del cross f dot n cap into ds. Okay, so along the surface S. So this must be equal to line integral. So this is our surface S. Okay, so the curve C will be this one. This is our curve C. So the curve C is this one. This is our curve C. So this is x and this is y. So we have the curve C like this. So let us draw the curve C with a different color. Okay, so this is our curve C. Okay, so this is our surfaces and this is our curve C, that is lying in the xy plane. Okay, so this is equal to surface integral, sorry, this is equal to line integral along the curve C. So this is curve C f dot dr. Okay, so we have, so this is equal to, the coordinate of this is 2 comma 0. Okay, and this is lying in the xy plane. So z is obviously 0, so we are ignoring the z coordinate. So this is 2 comma 0, this is 2 comma 2, and this is 0 comma 2, and this is 0 comma 0. So let us name this. So this is O A B and C. So this is our curve C. O A, this is B and this is C. So the value of line integral along the curve C f dot dr is equal to line integral along OA plus line integral along AB plus line integral along BC plus line integral along CO. Okay, so on OA we have y is equal to 0 and x varies from 0 to 2. Okay, now on AB we have x is equal to 2 and dx is equal to 0 and y varies from 0 to 2. Y varies from 0 to 2. On BC we have y is equal to 2, dy is equal to 0 and x varies from 2 to 0. Okay. On OC we have, on CO we have x is equal to 0 and dx is equal to 0 and y varies from 2 to 0. Okay. So let us calculate f dot dr. So f dot dr we can write as f dot dr is, this is y minus z plus 2 into dx plus yz plus 4 into dy minus xz dz. This is the value of line integral along the curve C. Okay, so on xy plane we have the value of z as 0. So let us take z as 0. So this is 0, z is equal to 0, this is 0 and this is straight away 0. So this is equal to y plus 2 dx plus 4 dy. This is the value of line integral. Okay, let us calculate this particular value. Okay, so we have the value of f dot dr. Let us write down somewhere here. So f dot dr is f dot dr along the curve C. This is equal to 4 y plus 2 dx plus 4 dy. Okay, so let us calculate one by one. So we have f dot dr along the curve C. This is equal to along OA. Let us place the value along OA. So along OA we have y is equal to 0. So this will be 0 and we will left with 2 times of dx. Y is equal to 0. Okay, y is equal to 0. So dy will also be 0. So this is 2 dx. And it varies from, x varies from 0 to 2. So 0 to 2 plus. Now along AB. So along AB we have x is equal to and dx is equal to 0. So dx equal to 0. So this term gets vanished. So this is 4 times of dy and y varies from 0 to 2 plus along BC. So along BC we have y is equal to 2 and dy is equal to 0. So dy is equal to 0. This means this term gets vanished. That is this one. And we have y is equal to 2. So this will be equal to 2 plus 2. This is 4 dx. And x varies from 2 to 0, 2 to 0 plus along CO. Along CO we have x is equal to 0 and dx is equal to 0. So this gets valued. This is 4 times of dy. Y varies from 2 to 0. Okay. Let us calculate this. So this is 2 times of 2. This is 4 times of 2. And this is 4 times of minus 2. And this is plus 4 times of minus 2. So this is equal to 4 plus 8 minus 8 minus 8. This gets cancelled. This is equal to minus 4. Okay, so the value of this surface integral that we have to calculate, that is, we have to calculate the value of surface integral, that is del cross f dot n cap ds along the curve C. So as per Stokes theorem, this is equal to, sorry, along the surface S, this is equal to, along, as per Stokes theorem, this is equal to line integral, that is along the curve C f dot dr. Okay, and this value is equal to minus 4. Okay, so we have calculated the value of line integral. This is equal to minus 4. So the value of surface integral is also minus 4. Okay, now let us discuss question number 15. Let us discuss question number 15. So in question number 15, we have to verify Stokes theorem for f is equal to x square plus y square I cap minus 2xy j cap taken round the rectangle bounded by x is equal to plus minus a, y is equal to 0 and y is equal to b. Let us find this. So in question number 15, we have verify Stokes theorem. So value of f is given as, so f is equal to x square plus y square I cap minus 2xy j cap taken round the rectangle bounded by. So we have the rectangle like this. Let us draw the coordinate axis first. So this is our coordinate axis. This is x and this is y. So we have the coordinate axis as x is equal to, sorry, taken round the rectangle. So rectangle is bounded by x is equal to plus minus a. So this is x is equal to a. This is x is equal to minus a. And y is equal to 0. So this is y is equal to 0. And this is y is equal to b. Y is equal to b. So the rectangle is this one. So this is our rectangle, and this is our coordinate axis. Okay, so we have the rectangle as this is A, B, C and D. A, B, C, D is our rectangle. Okay, this is 0, 0. This is A, 0. Coordinate of point B. Coordinate of point B A is minus A, 0. Okay, and this is A, B. This is minus A, B. Okay, so now let us calculate, let us verify the Stokes theorem. Okay, so as per Stokes theorem, we have f dot dr along the curve C. Okay, curve C is ABCD. ABCD is our curve C. This is equal to surface integral curl of f dot n cap into ds. This is surface integral along the surface S. So let us calculate the value of curl of f. So the curl of f is equal to I, j, and k. Okay, and this is equal to curl of f is del cross f. So this is del upon del x, del upon del y, this is del upon del z, components of del operator. Now let us write down the components of f, that is vector point function. So this is equal to x square plus y square this is minus 2xy, and this is 0. So this is equal to I cap, this is 0 minus 0 plus j cap, this is 0 minus 0 plus k cap, this is minus of 2y, and this is del upon del y of x square plus y, so this is minus 2y. This is equal to minus 4y k cap. This is the value of curl of f. Okay, now we have to find the ds. So ds we can write as dx dy. Okay, so let us calculate this. So we have the surface integral, that is curl of f dot n cap ds along the surface S. This is equal to, the value of curl of f is minus 4y k cap, minus 4y k cap dot n cap is k cap into dx dy. Okay, so the x limit, let us place the value of x limit. So x limit is from minus a to plus a. So x is equal to minus a to plus a. And y is from 0 to b. Y is equal to from 0 to b. So this is equal to, we can this is minus a to plus a, so we can write down as 2 times of 0 to a, and this is 0 to b. This is equal to minus 4y, this is dx into dy. Let us calculate y first. So this is equal to minus 8 of, this is minus 8, and this is y square by 2. Y dy is y square by 2, and limit is b. So this is b square by upon 2 into dx. So integration of dx is x, and limit is a. So this is a. So this is equal to minus 4ab square. Okay, so the value of surface integral is minus 4ab square. So let us calculate the line integral. So if it is same, then we can say that Stokes theorem is being verified. So the value of f dot dr will be f dot dr. This is equal to x square plus y square dx minus 2x minus 2xy dy. Okay, so we have f dot dr along the curve C. This is equal to line integral along AB plus line integral along BC plus line integral along CD plus line integral along DA. So this is equal to, along AB we have y is equal to 0, and x varies from minus a to plus a. Okay, so y is equal to 0. So let us place y is equal to 0 here. So this is x square dx. Y is equal to 0. So 2xy dy is also 0. And limit is from minus a to plus a. Plus along BC. So along BC we have value of x as x is equal to a. So dx x equal to a is constant. So dx is equal to 0. So here dx is equal to 0. So this is minus of 2a into y dy, and y varies from 0 to b plus CD. Along CD we have y is equal to b. So dy is equal to 0. So dy is equal to 0. This means 2xy dy is 0. So this is equal to x square plus y square. So y is b. So b square into dx. Okay, into dx, and x varies from a to minus a. a to minus a. a to minus a. ठीक है, plus. So along dA we have x is equal to minus a, that is constant. So dx is equal to 0. So dx is equal to 0. So this is equal to x equal to minus a. So this is 2a y dy, and y varies from b to 0. Okay, so this is equal to, this we can write as 2 times of 0 to a. 2 times of 0 to a. Okay, and this is this we can reverse. So we can take minus outside. So this is minus a to plus a. So minus a to plus a we can write down as 2 times of 0 to a. Okay, and this we can write as minus of 0 to b. We can reverse this with by taking minus outside. Let us write down this. So this is 2 times of x square ds. So this is a cube upon 3. This is minus 2a into y square by 2, b square upon 2, minus. This is minus 2, and this is x square ds, and limit is 0 to a. So this is a cube upon 3, and this is minus 2ab square. This is minus 2a into y square by 2. So this is b square upon 2. This gets cancelled. So this gets cancelled, and this is minus ab square. So minus ab square minus ab square minus 2ab square. This is minus 4ab square. Okay, so the value of line integral is also minus 4ab square. So line integral is also minus 4ab square, and surface integral is also minus 4ab square. So this means Stokes theorem is being verified. Okay, so now let us discuss question number 16. Let us discuss question number 16. So we have evaluate f dot dr along the curve C by Stokes theorem, where f is given by this particular expression and C is a boundary of a triangle with vertices this one. Okay, so z coordinate is 0 here. Okay, so in all the three cases, in all the three vertices, this one and this one, z is 0 here. Okay, so we have the triangle is lying in the xy plane. Okay, let us solve this. Evaluate f dot dr by Stokes theorem. Okay, so we have the value of f as f is given as f is equal to y cube I cap plus x square j cap minus x plus z k cap. Okay, this is the value of f, and C is the boundary of a triangle with vertices. So this is our triangle. The coordinate are 0, 0, 0, 1, 0, 0. So we have the coordinate as 0, 0, 0. Second, we have 1, 0, 0, and third is 1, 1, 0. So in all the three vertices, this is 0, z is 0, z is 0, and z is 0. This means this triangle is lying in the xy plane. So let us take xy plane. This is x and this is y. So we are not writing the z coordinate. Okay, so we are taking it as 0. So we are ignoring this. Okay, so we have the coordinate as this is 1, 0. This is 1, 0, and this is 1, 1, and this is 0, 0. So this is our triangle. This is O, this is A, and this is B. This is OAB. So this is our triangle. So we have from the Stokes theorem, f dot dr along the curve C. This is equal to curl of f dot n cap into ds along the surfaces. Surface S is triangle AB, triangle OAB. Okay, and curve C is OAB. This is our curve C. This is our curve C, and n cap will be k cap because this triangle is lying in the xy plane. So value of n cap is k cap. So let us calculate curl of f. So curl of f, how we can calculate? So curl of f, this is equal to I, j, and k. This is del upon del x, del upon del y. This is del upon del z. And value of components of f is, this is y cube. Sorry, y square, no? Y square x. This is y square. This is x square. This is minus x plus z. So this is equal to I cap. This is 0 minus 0 plus j cap. This is 0 minus this is plus 1 plus k cap. This is 2x. This is 2x del upon del x of x square 2x. So this is minus 2y. Okay, so this is equal to j cap plus 2 times of x minus y k cap. This is the value of curl of f. Okay, so now let us calculate curl of f dot n cap into ds. Okay, so we have to evaluate the line integral. So line integral is equal to surface integral. So let us calculate the value of surface integral. So whatever value we are getting for the surface integral, so the same will be for the line integral. Because as per Stokes theorem, line integral is equal to surface integral. So let us calculate the value of this surface integral. So whatever value we are getting for the surface integral, the same value is for the line integral. Okay, so we have the value of curl of f as this one. So we have the surface integral along the surface as curl of f dot n cap ds. So this is equal to, this is curl of f, that is I cap plus 2 times of x minus y k cap dot k cap into ds. ds we can write as dx dy. Okay, along the surface S. So this is equal to, this is dot product with k cap. So we are left with this term only. So this is 2 times of x minus y into dx dy. Okay, so let us take a strip here for integrating this. Let us take a strip like this. Okay, so this strip will move in this particular fashion. So this way this will cover the whole area of the triangle. So this is, so x limit on this strip is, x varies from 0 to 1 and y varies from, so this is y is equal to 0 and this is, equation of this line is y is equal to x. So this y limit is from y is equal to 0 to y is equal to x. So let us place the limit here. So x varies from 0 to 1, x is equal to 0 to 1 and y varies from this point is y is equal to 0 and this point is y is equal to x. Y is equal to 0 to y is equal to, okay. So let us calculate this. This will be equal to, let us name this as I. Let us further simplify this. So we have the value of I as I is equal to 0 to 1 and this is y is equal to 0 to y is equal to x. This is 2 times of x minus y dx dy. So let us integrate this with respect to y first. So let us take 2 outside. This is 0 to 1. This is xy minus y square upon 2 into dx. xy minus y square upon 2 and limit is y is equal to 0 to x. This is dx. So this is equal to 2 times of 0 to 1. This is x square minus x square upon 2 into dx. This we can write as x square minus x square by 2 is x square upon 2. This gets cancelled. So this is equal to x square ds. So this is x cube upon 3 and limit is from 0 to 1. So this is equal to 1 by 3. So the value of line integral is 1 upon 3. Okay. So we have discussed up to question number 16. Okay. So this is all about the Stokes theorem. Thank you.